Now, how do you find the inverse? Well, there are really two methods. Method number one says form an augmented matrix with A and the identity matrix. Do row operations until you have the identity on the left, and what's on the right will be your inverse. This method always works. Method number two, which I'm going to show you later, only works for 2 by 2 matrices. It will not work for 3 by 3, 4 by 4, and beyond. So, they give us a matrix and they say find the inverse. Let's start by using method number one. This one always works even though it's a little bit messy. We start by writing this matrix on the left and we attach to it the identity matrix on the right. So we have an augmented matrix like this. Now what we want to do is do row operations, getting a 1 in the top left corner and all that fun stuff, until we have the identity on the left. Well, I don't see an easy way to create a 1 in the top left corner, so we're just going to have to do this by brute force and say 1/5 of row 1 is the new row 1. So here we go. Row number 1 becomes 1, -3/5, 1/5, and 0. And the bottom row is going to stay 10, -7, 0, and 1. Now that we have our 1 in the top left corner, we need a 0 beneath it, which means I need to cancel that 10 out with a -10. So -10 row 1s plus row 2 becomes the new row 2. That means the top row stays as it is, 1, -3/5, 1/5, and 0. And here we go. -10 times 1 is -10, plus the 10 beneath it is 0. -10 times -3/5. Well, first off, negative times negative is positive. 3/5 of 10 is 6, plus the -7 makes a -1 in the next row. -10 times 1/5, that's -2, plus the 0 beneath it, -2. -10 times 0 is 0, plus the 1 is 1. So we got by that without as many fractions there. Okay, now we need to get a 1 where the -1 is, which means negative row 2 will become the new row 2. And let's do that operation. First row stays 1, -3/5, 1/5, and 0. The next row becomes 0, 1, 2, and -1. And we need finally to get a 0 where that -3/5 is. So I cancel a -3/5 out with a +3/5. So 3/5 row 2 plus row 1 is the new row 1. And here we go. We will have the identity matrix on the left here. You know that row 2 is not going to change, so we're going to keep the 2 and the -1 down there. Now we just need to finish off the first row. 3/5 times 2. That's going to be 6/5 plus the 1/5 there to get 7/5. Then 3/5 times -1 is -3/5 plus 0 is -3/5. So we now have the identity matrix on the left, and what's on the right there is our inverse matrix, and we write that as A inverse is equal to, and here we have it, 7/5 on the top left, -3/5 on the top right, 2 on the bottom left, -1 on the bottom right. Now that's method number one, and it's a little bit tedious. Now let me show you method number two, and it uses determinants, which is something we're not going to learn until the next section, but I'm going to go with it anyways here. Here's my memory technique. I know that the percent sign looks like this. I change it to a backward slash instead, and I put minuses in the other two positions where those little zeros were. And my shortcut method says, and this only works for 2 by 2s, A inverse is equal to 1 over the determinant of A times what you get when you switch the positions in the first position of the first row and the second position of the second row and change the sign of those other two positions. Okay, let's talk about determinants here just for a second. The determinant of A in our case is going to be this determinant here, 5, 10, -3, and -7. I'm going to multiply down this main diagonal. 5 times -7 makes -35. The other diagonal I'm going to multiply upward to get -30, but change that to a +30. I'm going to add those two values together to get -5. Now, my shortcut says A inverse is 1 over the determinant. So A inverse is 1 over -5 times. Now I'm going to switch positions of the 5 and the -7, putting the -7 on the top left and the 5 on the bottom right. And I'm going to change signs of the -3 to make it a +3 and the 10 to make it a -10. And I'm going to now multiply by that -1/5 out front to get 7/5, -3/5, 2, and -1, which is a lot faster than doing all those row operations.